Okay, we're back with our video. In 3.1, this is going to be like part 2 of that section. And we're going to go ahead and take a look at applying some of those rules we addressed in the first video and see how these work. So sometimes we'll just cut to the chase with these, but a lot of times we'll just kind of take these with a closer look. So if you have any questions about how these are done, we'll kind of take a long approach to everything. So we'll take two approaches. We'll apply the rule directly, and then we'll show why the rule applies. Especially in the beginning, that's going to help make a lot of sense of these. All right, so let's just take a look at 3 squared. Now, this is something that you could even do in a calculator very simply, but 3 squared, that's equal to 3 times 3. The exponent tells me how much I repeat the multiplication. So that's going to be twice. That's going to be equal to 9. Now be careful in a question like number 2. So in this question, the only thing that gets raised to an exponent is the 3. So if I have negative 3 squared, then this gets written out as just negative 3 times 3. It's only the 3 that's being raised to the exponent, not the negative. Therefore, this result is going to yield a negative 9. If we wanted a result that yielded positive 9, we would need to add one thing to the question here. And that is, we would need to take the quantity of negative 3 and put that in parentheses. And this result would yield the work negative 3 times negative 3. So with the inclusion of the parentheses, we not only have the 3 raised to the second, we also have the negative raised to the second. So we still have 3 times 3 being equal 9, but now we have a negative times a negative, and as you know, a negative times a negative should be positive, giving us a positive result as compared to the negative result. Since the question asks this, our final answer should be negative 9. But just know that if you see a question that looks like this, and it has a parenthesis, that we have to square both the 3 and the negative on the inside. So parentheses with exponents are very important. Let's take a look at this further. Okay, so we're going to try this question 2 different ways. One will apply the rule directly that we learned about, and I believe for this one, this is going to be the power of a fraction rule. And then we're going to also draw this out the long way. So this is going to be 1/4 to the third, and I'll write this out 2 times here. So the power of a fraction rule says that I just write this as 1 to the third, and write this as 4 to the third. And if I do that, that gives me 1/64. And by the way, you can do this on your calculators, and your calculators may give you decimals and answer. Just be prepared that the answer you should be prepared to show for these should in fact not be a decimal but a fraction. So be ready for that. The long way of doing this, and the reason why we get 1/64th, is if we have 1/4, like what's inside the parentheses raised to the third, it's 1/4 times 1/4 times 1/4, giving us 1 to the third, giving us 4 to the third, or again 1/64. So here's applying the rule directly. Here is why the rule works that way. So again, I am including not just the application of the rule, but also an explanation of why the rule works the way it does for a better understanding. Especially important if you're trying to differentiate between what rule or rules to apply. Let's take a look at the next problem now. We have here negative 3 times 2 to the third. So hopefully if you can remember, in terms of order of operations, what comes first, what should come first are the exponents. So what I'm going to do is I'm just going to underline 2 to the third, and that's going to give me 8, and then I'm going to bring everything else down. So this is going to be negative 3 times 8, and if I multiply that together, that should give me 24, but a negative 24. A question like this, you should be able to put directly into your calculator and have it generate an answer. But if you put it into a calculator, it's probably going to look something like a negative. Now, not a minus sign, but a negative. 3 times 2, and most likely you're going to have something with a caret to show the exponent, and then the exponent's going to be 3. So if you put a question in like that, just know that for the exponent, you may have to use a caret to capture the exponent to raise 2 to the third properly. Okay, let's see. Oh, guys, I'm sorry. I just noticed that you're coughing the work a little bit here. Hopefully, you will understand what I did there, and I will leave that up for a little while longer so that you can take that in a little bit more, and I'll go on to the next question. So, yeah, I don't have a ton of time to go edit all these videos, so I won't make any changes. If I make mistakes, I go on. All right, so here it says to evaluate. So when it says to evaluate, that just simply means find the value. So it wants us to find the value of 3xy squared when x is equal to 5 and then y is equal to 2. So what that means is, since it's implied that multiplication is between all of these operations, I'm going to write this out as 3 parenthesis 5 and then parenthesis here 2 squared. Now, if you do a question like this on a calculator, you should be able to put this as 3 times 5 times 2. Now, most calculators you can actually type in the exponent of 2. In case you can't, just go ahead and put a caret and put 2 there, and the calculator will take care of the order of operations for you. However, if you still want to see this done by hand, I'm happy to oblige by that. I'm going to go ahead and take care of the exponent here first, and that's going to give me 4. So I'm going to have 3 times 5 times 4. 3 times 5 is 15, times 4, that's going to equal 60. And 60 should be your final answer to question 5. I'm going to go ahead and move it up now so I have all the problems from the remainder of the page on here. Number 6, evaluate the expression with the given replacement value when z is equal to negative 2. So let's take a look at how this works when we're evaluating a negative number. So we have the expression 3z to the 4th divided by 7. So this is going to be 3. This is going to be, what's z? Negative 2. I'm going to put that in parentheses and raise it to the 4th, all divided by 7. So when you're doing this, probably the first thing you want to do first is raise negative 2 to the 4th if you have a hard time putting this in the calculator at once. Now, if you do that, if you take negative 2 and raise it to the 4th, you're going to have to type this in as negative 2 parenthesis caret 4. So if you type in this negative 2 without a parenthesis, it will not raise the negative to a 4th, giving a wrong answer. If you do it correctly, though, you'll find that's going to give you 16. So let's go and replace this value here. So we get 3 times 16 over 7. And at that point, if we take 3 times 16, that's going to give us 48 over 7. And our final answer is just going to be left as a fraction. Now, when you're taking a test, oftentimes it's not unusual at all to have an answer that's going to remain and end up being a fraction. And you should be just ready to kind of accept that, and especially if you're doing a test that's multiple choice, the expectation is you're going to show your answer as such. So if the calculator comes in handy, it's more than just throwing stuff in a calculator and then just coming up with whatever the calculator spits at you. All right, let's take a look at the last question here. It says use the product rule to simplify the expression. So if you recall what the product rule says, if you have 2 common bases being multiplied, and we do in the base in this case is z, that we're going to go ahead and then write that base out and make this 10 plus 6, and that's going to equal z to the 16th. Now, here's where the rules are really important. And I'm going to take advantage of the fact that I have some space at the bottom of this paper to kind of illustrate this. Because if I have z to the 10th times z to the 6th, if I had to do this the long way, let me just bring this as the big multiplication sign here. What does z to the 10th look like? It looks like z times z times z times z times z times z times z 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7 times z times z times z. That's z to the 10th times how many more z's? Z times z times z times z times z times z. And I would write z to the 6th as z 6 times. If I got to count these up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, well, that's just a pain in the you know what. So if you can remember that you just can add these numbers together, the exponents together get z to the 16, that is going to make your life just a little easier. So going from the first page now, let's go ahead and take a look at how we do the next few problems here. It says use the product rule to simplify the expression. Write the results using exponents. So in this question here, what is it asking? Use the product rule to simplify the expression. So that means we're going to be either adding the exponents. We have to make sure that if we do that, though, the bases have to be identical. This is -7. This is -7. If we're looking at things with different signs, wouldn't quite work. So we have to be sure to be consistent. So we have -7 to the 2 times -7 to the 8. Then we will write this as -7 to the 2 plus 8, or this is going to be -7 to the 10th. Now, you could, if you put this on a calculator, actually get a number. But what's it asking for? It says write the results using exponents. So it's not looking for what -7 to the 10th is. And by the way, if you take 7 to the 10th or -7 to the 10th, it'll be a positive answer, but it'll be a very large number. So it's not asking for that. It's asking us to express this answer in terms of an exponent. So be careful when you're reading the directions for this, like on a test. If you give me a very large number, I'm not accepting that as an answer. If it asks for it to be written, the result to be written with an exponent, that's what I'm going to be expecting. Okay, so that's going to be question 8. Let's take a look at number 9. It says use the product rule to simplify the expression and then write the result using exponents. Okay, so again, we're going to be looking at things with exponents. You'll take a look at here is that we have two terms that are being multiplied. The first term is 2z to the 3rd. The other one is going to be 3z. So a few things going on here. First off, you'll recognize that 2 and 3, these are different. And that's okay. In applying the product rule here, the 3 that's an exponent here is not an exponent on 2z. It's only an exponent on the z. So we have this z here, we have this z here. And because there's no exponent on this z, it may be easier for people to go ahead and just write a 1 in for that. So in terms of the numbers, we have multiplication here, so this is still going to be 2 times 3. And 2 times 3, that's going to give us 6. Here, if you have z to the 3rd times z to the 1, that's going to give me z to the 4th. So really what you've got going on here is you have 2 times 3 times what? Z to the 3 plus 1. And that's what's going to yield for us 6 times z to the 4th. So here it is, just kind of the work shown, and then here's a little bit exactly how we obtain that answer. Okay, let's take a look at another problem. We have a to the 6th, in parentheses, b to the 3rd, times a to the 15th, times b. So first thing to note is, not all the variables have exponents. They do, it's just not visible. Remember we talked about what's implied. So if a variable is in this mix that doesn't have an exponent, might make it easier to just kind of see things and put a 1 there. Since everything is being multiplied here, there's no addition sign, there's no subtraction sign, there's nothing else in sight, I'll just go ahead and rearrange this a little bit. So what I'm going to do is I'm going to take a to the 6th, and then I'm going to just bring this a to the 15th down, times b to the 3rd times b. So what I did is I bring the a's together, I bring the b's together. The work again, this is going to be a to the 6 plus 15. This is going to be b to the 3 plus 1. So as an answer, this is going to come out to be a to the 21, b to the 4th. And instead of trying to show the explanation of this the long way, I really don't feel like writing out 21 a's, and I think hopefully by now or soon people will kind of get the gist of what that looks like. So I'm going to move this up now, but if you need to see this, you can go ahead and play this over again. Bring this up to here. And now it says use the product rule to simplify the expression. Write the result using exponents. Okay, so in this problem here, let's see what we have. So first off, we have negative 5y z to the 7th. We have 3y to the 3rd z to the 2nd. Notice here that there are no exponents on the outside of the parentheses, so we wouldn't have to be concerned about that yet. So what I'm going to do, since I have nothing but multiplication going on here, is I'm going to kind of bring the numbers together. So I have negative 5 times 3. Okay. Times. Now let's bring the y's together. This is 1. Y to the 1 times y to the 3. And then this is going to be times z to the 7th times z to the 2nd. So if I go ahead and I first off do this, negative 5 times 3 will be negative 15. 1 plus 3, that'll be y to the 4th. For z, 7 plus 2 will be z to the 9th. Giving me my final answer of negative 15, y to the 4th, z to the 9th. Let's go on and take a look at number 12 here. It says the rectangle to the right has a width of 3x to the 5th and length of 6x to the 3rd feet. Find its area as an expression of x. So one thing that can make this question difficult is if you don't know how to find the area of a square, then you have to know that area is going to equal, or area of a rectangle I should say, that area is equal to length times width. So you need to know that formula. I'm going to go ahead and I'm going to label this measurement as the length. I'm going to label this measurement as the width. And I'm going to substitute in that formula over here. So I'm going to have A equals length times width. That's going to be 6x to the 3rd times 3x to the 5th. And again, as I multiply things together, I'm going to carry out this work down here. That is going to give me, let's make sure everything is visible. Yes, it is. It's going to give me 6 times 3, putting these together, and then times x to the 3 times x to the 5th. And my final answer for that is going to be written as 18x, 3 plus 5, 18x to the 8. And it wants the dimensions of this. So if you're going to find the area of something, we always write the area as being in square feet. Or square something, whatever that unit happens to be. But since we're looking in terms of feet for each measurement of the sides, then the area is going to be in terms of square feet. Let's go ahead and take a look at 13 now. It says use the power rule to simplify the expression. So we have y squared to the 3rd. Now the power rule, remember what the power rule says. It says we're going to multiply these things. So we're going to do this using the rule, and then we'll apply it the long way. So y squared to the 3rd. The power rule says take y to the 2 times 3, or take y to the 6th. And then here, this is going to be, if I take y to the squared and raise it to the 3rd, this will be y squared times y squared times y squared. Y to the 2 plus, so this would be like then y to the 2 plus 2 plus 2 gives me y to the 6th. So this is the short way of doing it. This would be kind of the long way. I'm not going to do it again for this next example because that would be just way too much writing. Okay. Now it says use the power rule and the power of a product rule. So it sounds like we're putting two things together at once, and in fact, we are. So what I'm going to do is I'm going to write this question just a little differently. So I'm going to have 2, and then I'm going to have b to the 3rd. And I'll put that in brackets. I'm going to write that to the 6th. So when I bring this through, like the 6 to the 2 and the 6 to the b to the 3rd, that's going to be the power of a product rule. So what that means then is I'm going to take 2 to the 6th and then b to the 3rd to the 6th. So everything on the inside is each getting raised to the 6th. Here, if I take 2 to the 6th, that's going to leave us with a number. And it just says simplify the expression. So if, if it's asking for something like that, we can take 2 to the 6th, and that is going to equal, let's see, 2, 4, 8, 16, 32, 64. So that's going to be 64 because that's 2 to the 6th. B to the 3rd to the 6th, that's going to be 3 times 6. Okay, so 2 to the 6th times b to 3 times 6, and that'll be b to the 18th. So this is going to be a 64 b to the 18th. All right, let's go ahead and take a look at some more problems from this section. You'll see that this section contains more homework just because there's so many little rules that you need to acquaint yourself and become comfortable with. So it says use the power rule and the power of a product quotient or quotient rule to simplify the expression. Okay, so we're getting into some of these other properties now. So we have this 2 on the outside of this, so let's see how this is going to work now. So let me write the problem again. Now, this time I think I'm actually going to use the back of a paper for addressing some of these. So I can show the work kind of cleanly here, because this one's going to have a little bit more work than I'm given room for. So this is going to start off as the quantity of negative 8, a to the 5th, b to the 7th, times c, and that's going to be raised to the 2nd. What I'm going to do is I'm going to take everything on the inside, and I'm going to give each thing its own parenthesis. So I can have negative 8, parenthesis, a to the 5th, parenthesis, b to the 7th, parenthesis, c, parenthesis. And every little thing on the inside, kind of like distribution, but this is a distribution on an exponent across every single part of a term. This is all one term on the inside, but every single part of the term is going to get this exponent. So negative 8 will get squared. A to the 5th will get squared. B to the 7th will get squared. C will get squared. And when I compute that out, this is going to give me here negative 8 squared. That's negative 8 times negative 8. It's going to be positive 64. This is going to be 5 times 2. Because remember, you multiply these together. That's what that rule says. That gives me a to the 10th. 7 times 2 gives me b to the 14th. And because the c is by itself, this is 1 times 2, or c squared. So my final answer to question 15 is 64, a to the 10th, b to the 14th, times c squared. Okay. And the next problem here, let's make sure I can see that. Yes, okay. Use the power rule and the power of product or quotient rule to simplify the expression. Assume that all bases are not equal to 0. So let's apply something similar to what we did. So I'm not writing this out 8 times. So if I have m times p over n, and that's all to the 8th. Just like when I had everything in the previous problem, what I'm going to do is I'm going to take the m, put it in its own set of parentheses. I'm going to take the p, put it in its own set of parentheses, and then take the value of n, put it in its own set of parentheses, and each of them are going to get 8 on the outside, giving me m to the 8 times p to the 8 over n to the 8. And that's going to be question 16 done. Not so important that I show that work here. And just one thing to remember, these all have exponents of 1, so that 1 times 8 is 8, 1 times 8 is 8, and 1 times 8 is 8. Because in the next problem, the work on this is a little more complex. So I'll go ahead and write this one out. This is going to be written as 9x squared z to the 5th divided by y to the 5th. So I'm going to, and this is all to the 3rd. So what I'm going to do is I'm going to write each part of this out in a parenthesis, 9 x squared z to the 5th over y to the 5th. And each of these is going to get an exponent of 3. Let me kind of highlight that in a slightly different color to make it a little more visible to see. So here's my 3 here. 3, 3, 3, 3. And all those are going to multiply the exponents on the inside. For this one, 9 to the 3rd, you can check this on your calculators if you want. But when you carry that out, that's going to equal 729. I could be wrong, but I think that's correct. 2 times 3 will give me x to the 6th. 5 times 3 is going to give me z to the 15th. 5 times 3 will give me y to the 15th. And that's going to be the answer to question 17. By the way, anytime you want to try these on your own, and you just kind of stop this and you go on from there. Okay, so I'll show this question 18, the short way and the long way. The short way says if you have x to the 6 divided by x, this is a 1. So I can write this as x to the 6 minus 1, or I can write this as x to the 5th. The other way to do this, and I'll kind of just bring this over here a little bit, if I have x to the 6 divided by x, is I can write this out a long way here as x times x times x times x times x times x, all divided by just x. Leave me with 1, 2, 3, 4, 5, or x to the equals x to the 5th that way. So 2 ways to get at the answer, but if you know the rule for it, that will certainly help. Okay, let's take a look at next problem here, number 19. So we have, writing this out, this is going to be p to the 5th times q to the 5th divided by p to the 2nd times q to the 3rd. So what we're going to do now is we have the p's here with a 5 and a 2, so this is going to be p to the 5 minus 2 times q to the 5 minus 3. 5 minus 2 will give me p to the 3rd. 5 minus 3 will give me q to the 2nd. And that's going to be my answer for question 19. 20, very simple one. Anything that's raised to a 0 exponent, that's just going to equal this. So 5x to the 0, because everything's on the inside. If there was something out here, this may be a little different, but this whole thing equal to 1. I have a few more questions to go through here. Now this one's a little different. Hold on, here we go. Here, if we're looking at this, we have negative 10x to the 0. Well, in this one here, only x is raised to the 0, making that 1. What's this being multiplied by? Negative 10. Therefore, negative 10 times 1 is equal to negative 10. So that final answer is going to be negative 10. So you have to be careful to watch what's being raised to the exponent. Next one here is a problem we talked about earlier. If you have negative 5 squared, it's only the 5 being raised to the exponent. 5 squared is equal to 25. Negative comes down. And that's going to be negative 25 for an answer. Almost done here. I just have 3 more problems. In the next one, I have negative 4z squared times 5z to the 5th. 4 times 5 is going to give me negative 20. Z to the 2nd times z to the 5th, that's going to be z to the 7th. In the next one here, I'm going to go right for the solution on this here. So we have the quantity of negative 6 x y z squared. That's all squared. Negative 6 squared, I squared the negative in the 6. That's going to be 36. X, these are all 1, so this is x squared, y squared, z to the 4th. And then finally on the last one, without showing a ton of work here, if I put this through, so my answer is 2y to the 6th divided by 8z to the 5th to the 3rd. 2 to the 3rd, 8. Y to the 6th to the 3rd, y to the 18th. 8 to the 3rd, that's going to give me 524, I believe, but I could be wrong about that, but I think that's correct. Z to the 5 to the 3, 5 times 3, that'll give me z to the 15th. Now, if I take 8 and I divide it by 524, I'm not sure about that calculation. Yeah, just check that quickly here a minute, ladies and gentlemen. I want to make sure I'm doing this correctly. So, hold on. 512. Okay, so this is going to be 512. If I take 512 divided by 8, that is, so if I take 8 and it divides into 512, this is going to give me a 64 below. Okay, so I'm taking this, dividing it by 8, taking this, dividing it by 8, and that's going to be y to the 18th over z to the 15th. That concludes our lesson in section 3.1.